We already studied the function f of x equals x to the 1/2, although at the time we called it f of x equals the square root of x. So if we already learned about the square root function, why should we introduce this new way of talking about it? One major reason that it is nice to use the form f of x equals x to the 1/2 is that we can use all of our rules of exponents that we've discovered. Let's remind ourselves of what we learned about the square root of x. We learned how to graph y equals the square root of x, and using our graph shifting, we could graph more complicated functions like y equals the square root of x minus 2 plus 3. We also learned about the domain of this function. For y equals the square root of x, we saw that the domain is x must be greater than or equal to 0. And for y equals the square root of x minus 2 plus 3, we saw that the domain is x must be bigger than or equal to 2. So where do these restrictions on the domain come from? For the square root of x, the domain is that x must be bigger than or equal to 0, because if we take the square root of a negative number, we no longer get a real number. So what we're taking the square root of, in this case x, must not be negative. And for the function f of x equals the square root of x minus 2 plus 3, we're taking the square root of x minus 2. So that must not be negative. In other words, x minus 2 must be bigger than or equal to 0. But this gives us our domain, which is that x must be bigger than or equal to 2. In general, the domain of a function f of x equals the square root of something else, call it g of x, is all the values of x so that g of x is bigger than or equal to 0. Because this notation is a little bit messy, it's worth pointing out that in f of x equals the square root of x, what we're calling g of x is just x. And in f of x equals the square root of x minus 2 plus 3, what we're calling g of x is x minus 2. In other words, g of x is what's underneath the square root.